Hey, welcome back, Giants. Today we are going to start Chapter 2, and our first thing in Chapter 2 is a few vocabulary words. So go ahead, write these 3 words down. If you need more time, pause the video. But our first word here is a conjecture, and this is a mathematical statement. It appears to be true, okay? It's not been formally proven, but it's initially when you hear it, it appears to be true, okay? Our second vocabulary word today is inductive reasoning. This is a form of reasoning in which a conclusion is reached based on a pattern present in numerous observations. Okay, so based on what you continue to see time and time again, you can use inductive reasoning to make some sort of conclusion. And our final word, counterexample, for this, think in sports. I'm a soccer coach, and in soccer, a counterattack is when my team steals the ball and quickly attacks the other way. A counterexample kind of goes the opposite way. It disproves something. Okay, so it's a special kind of example that disproves a statement or proposition. And if there's one counterexample, then the statement is no longer true. So sometimes we might have a conjecture, and then we find a counterexample and we see that it actually wasn't true. So once again, if you need more time, go ahead and pause this so you can get these 3 words down. Otherwise, we're going to start looking at patterns now. So, excuse me, here we have some visual patterns. It says sketch the next figure in the pattern. And as you can see, each of these is a grid of 9 boxes. So hopefully using inductive reasoning, we can conclude that the next one will also have 9. So we want to draw a similar shape, and now we need to figure out where are we going to shade. Now if we look here, on all 3 of them, the middle square is shaded. Okay, so the middle square will still be shaded for us. Now if you look, it rotates which corner is shaded. Top left, top right, bottom right. So next will be bottom left. If you think about it, it looks like this shape is being twisted. It's turning on its side over and over. If we rotate it to the right, it ends up here. If we rotate it again, it ends up here. If we rotate it one more time, it ends up down here. And the final one will have to be in this top area. So obviously my picture doesn't look perfect, but it's generally the next figure in the pattern. Now this next one. And if you want to have time to think, you can pause it and try to figure it out. But we've got 3 dots, then we have 6 dots, and then we have 10 dots. Each time a new row is added. And it was 2 on the bottom, then 3, then 4. So in our case, we're going to have 5. And some of you are probably really good at visual patterns. Some of you, maybe it's a little more difficult. That can kind of depend on what learning style you tend to have, but just give it a try. Take a look at this next one. See if you can draw. You don't have to draw all this out, but maybe pause the video, see if you can draw the next figure here. While you think about that, did anyone ever play Break the Ice growing up? These remind me of Break the Ice, the little ice tablets that you have to hammer out with the hammer so the guy doesn't fall in. So anyway, it's kind of our stair steps. It starts with 1, then 2 on the bottom, then 3 on the bottom, then 4 on the bottom, then 5 on the bottom. So in our case here, we're going to have 6 on the bottom. Might have made it too tall. Let's see, 1, 2, 3, 4. There. A little too tall, but I have 6 on the bottom. I guess technically I should shade that in so it looks the same. So obviously mine's not perfect, but you get the idea. All right, so now sometimes we have numerical patterns instead. So if we look here, it says describe a pattern in the sequence of numbers, predict the next number. So 128, then 64, then 32, then 16. Each time, hopefully you guys see it, It is dividing by 2. So the next one, 16 divided by 2 will be 8. And our next one here, 5, then 4, then 2, then -1. This one's a little bit more difficult to see maybe. It's not consistent. But if we look here, it's -1, then -2, then -3. So if we subtract 4, our answer, -1 minus 4, gives us -5. And that is our answer. Now, if we want to describe what's happening, each time subtract 1 more. Or subtract 1 greater, maybe is a better way to say it. All right, so now, those are numerical patterns. The next thing I want to talk about is our conjecture. And this is where we aren't going to formally prove it, but we're going to show several examples and kind of come up with some sort of conclusion that appears to be true. So the sum of any two odd numbers is blank. So first, sum means addition, if it's SUM, and any two odd numbers, so like 1, 3, 5, 7, 9, 11, etc. So first thing, let's come up with any two odd numbers. So I don't care what you choose. I'll do 3 plus 7. We get 10. Okay, two other odd numbers, 5 plus 9. I get 14. 11 plus 11, 22. Okay. Now, no matter what I choose, our answer is always even. Now, on our next one, says, what conjecture can you make about the number of regions 20 diameters form? So we look here at these pictures. First off, what does the word diameter mean? So a diameter is when it goes pretty much right here. It goes straight across the circle, through the middle, from side to side. And one diameter will form 2 regions. If we have 2 diameters, we get 4 different regions. So 3 diameters, 6 regions. If you wanted to, you could keep drawing this, or you could draw a circle and draw through 20 times, but that's going to be difficult. Instead, we want to look for a pattern. So 1 gives us 2, 2 gives us 4, 3 gives us 6. Hopefully you guys can make the conjecture that 20 diameters will give us 40 regions. All right, and then the final thing we want to do today is look at how a counterexample can show a conjecture is false. So right here, if the difference of 2 numbers is odd, then the greater of the 2 numbers must also be odd. Okay? So the difference of 2 numbers is odd. So for example, if I do 11 minus 6 equals 5. So difference means subtraction. Difference of 2 numbers is odd. 11 minus 6 equals 5. That the difference of those 2 is odd. The greater of the 2 numbers must also be odd. And in our case here, we did it. We showed that that is the case. However, that doesn't mean it always is the case. What if instead I did like 10 minus 3? That equals 7. The difference of those 2 numbers is also odd, but the greater one is an even number. So in this case, I have what is called a counterexample. And once I have one counterexample, it doesn't matter how many of the correct way I showed. As soon as I have one counterexample, this conjecture is false. It's no longer true about every scenario. So once again, here you can connect any 3 points to form a triangle. So initially that might seem the case. If I have 3 points there, pretty easy. Okay, no matter how I draw it, except there is one case that is a counterexample. And probably lots of you can think of this. If I put this right in line, there is no way I can draw a triangle. It's just a line. Those are collinear if you think back to chapter 1. So go ahead, there's a few patterns to try for the day. Let me know if you have any questions. And if you didn't finish the test last week, make sure we get that done. Bye.